So in the speed of the end effector வந்து பார்த்தோம் அப்படின்னா it should be 50 inch per second. IPS stands for inch per second. So 75 அப்படிங்கிறது என்ன பண்ணும் அப்படின்னா it will instruct the robot to operate at 75% of normal speeds. So open and close, we know that it will instruct the end effector to open during the execution, it will open to close the during the executions. So இந்த I அப்படிங்கிறது என்ன அப்படிங்கிறது பார்த்தோம் அப்படின்னா it will cause the actions in order to occur immediately. That is, we have to open immediately, we have to close immediately. So அந்த மாதிரியான ஆப்ஷன்ஸ் இருக்கும். ஸோ அதே வந்து gripper வந்து which is controlled using a servo mechanisms அப்படின்னா we have to use the following commands. ஸோ இப்போ வந்து பார்த்தோம் அப்படின்னா open 40. So that is the opening should be of the 40 mm. அதே மாதிரி close அப்படிங்கும்போது we have to gripping force பண்ணணும் நம்ம. So grasp நமக்கு தெரியும். That is if the final opening is less than, so it has to be branches to the program. So it will be allowing the signal from output port to be turned on, off பண்றது. We'll be waiting for the wait command. So these are all the normal general commands which will be used in the valve programming. Similarly, we'll have a relational and logical operators இருக்கும். EQ அப்படின்னா equal to, NV அப்படின்னா not equal to, GT னா greater than, GE னா greater than or equal to, LT அப்படின்னா less than, LE அப்படின்னா less than or equal to, and logical operators, or operators, logical complement. So text அப்படின்னா வந்து will be indicating the quotations marks வந்து it will use to display the output informations. Text comma index அப்படிங்கும்போது will display the message or given in the quotation marks. So system வந்து waits for the input value. So in the most real life problems வந்து பார்த்தோம் அப்படின்னா program sequence control will be requiring over on it. Go to 10, that is we'll have unconditional branch to statement 10 over இருக்கும். If then, so if வந்து true, group வந்து then and else is executed. So else again வந்து பார்த்தோம் அப்படின்னா end, do. So until, so it எல்லாமே அப்படியே we'll have the logical instructions and a group of instructions over on it. Okay. Similarly, we'll have a exit, store, read, list, print, directory, erase, execute, abort, stop. இது எல்லாமே we'll be having over on it. So whereas in the case of an example one, we have to develop a program in Valve to command a boomer remote to unload a cylindrical part of 10 mm diameter. அப்போ என்ன பண்றோம் நம்ம? So position at the point P1 and the load and portion at part P2. So speed of robot வந்து 40 inch per second இருக்கும். Because of safety precautions வந்து 10 to பண்ணணும் நம்ம. So அப்போ signal 5, so we'll have a normal operation to be 40 inch per second. So approximately 50 பண்ணணும். We have to reduce to 10. We have to move the pen, grasping, detaching, speeding appropriately. So this command will be used to start over. Okay. So this is the way to drop over there. Then we have to see about the robot control. So robot control பார்த்தோம் அப்படின்னா that is we have a limited sequence controls இருக்கும். We can place operations using mechanical stop executions இருக்கும். When you're going for with the playback with the point-to-point control, we'll have a records work cycle as a sequence of points. Then we'll be having the playback sequence during the program execution. So continuous path control பார்த்தோம்னா we'll have a greater memory capacity or interpolation capability to execute the path. Intelligent control பார்த்தோம் அப்படின்னா it will exhibit behavior that makes it seem intelligent and will be responding to sensor inputs. We'll have drive systems. Already we all know that electric system, hydraulic system, pneumatic system. So electric systems வந்து it is used to actuate individual points. Hydraulic வந்து it is used for rotary vane applications. Pneumatic வந்து it is particularly for similar robots. So hierarchical control structure of robot microcontroller பார்த்தோம் அப்படின்னா we'll have an input or output, we'll have a storage, we'll have an executive process, we'll have a computation process. So we'll have the hierarchical control structure joint 1, joint 2 till joint 6 or on it. Closed loop control systems, and we'll have a open loop control systems. A system in which the output variable is compared with an input parameters, and any difference between the two is used to drive the output into agreement with the input overload. So controller, actuator, process, and then we'll have a feedback sensors. Open loop control system la feedback mattum varadhu. We know that it will be simpler and less expensive, and it will risk that the actuators will not have the intended effect. Control of manipulators பார்த்தோம்னா we'll have a linear control of manipulators, feedback and closed loop control. So block diagram, so we'll have a over on it. So linear control of manipulators வந்து initial and final location of end effector வந்து in partition space இருக்கும். Similarly, the inverse kinematics வந்து will model compute the desired end effector. So trajectory generator locations வந்து பார்த்தோம் அப்படின்னா which compute the joint position, time hysteresis based on the joint space algorithms. So depending on the servo control வந்து பார்த்தோம் அப்படின்னா it will be computed from the base reference values and the sensor instruments over on it. Okay. So this is the operations of point-to-point machine control. So the linear control techniques வந்து will be valid எப்போ அப்படின்னா which can be studied, which can be modeled mathematically by linear differential equations. Similarly, we have to calculate the joint position time. For the case of manipulator control, we have a linear manipulators. Similarly, we'll have often reasonable to make such approximations methods. Justifications are good. Delay control is reasonable control. So feedback and loop closed by such control system. The only way to build a high performance control in the path of makes use of feedback from joint sensors indicated in the figure. Typically, in this feedback, it is used to compute the servo error by finding the difference between the desired and actual quotient and then between the desired and the actual velocity. The control systems which can then compute how much torque is required as a function to reduce the servo error. The central problem of the Kalpana will be designing a closed loop system that meets certain performance specifications. First of all, system has to remain stable. We define a system to be a stable if the errors remain small. In executing various desired results. Second requirement of the Kalpana, closed loop performance of system is satisfactory. So in practice, on the Kalpana, we'll have such proof range from mathematical proofs based on certain assumptions and models to more empirical research through simulation. So manipulator control problem on the Kalpana, we'll have a joint control system. We'll have a joint controller 1, 2 till Rn and a manipulator joint 1 model to joint n models over on it. Okay. So this is the robot control architecture for NDOF manipulators over on it. Okay. So the remaining thing that we can see in the next class. Thank you all.